All right, so we're going to start now with our what should be our last section on the acoelomates and pseudocoelomates, and talk about some important parasites of humans. So that's kind of our next step here. I don't know why that happened. All right, so Diphilary immitis is dog heartworm, and clearly that's not a parasite that infests humans, but it can be important for human purposes because, of course, lots of people like dogs, and that can be a big issue for dogs if they're infested with heartworms and that's not treated. So that's one to think about that actually can be a factor for humans, at least economically, and of course for our furry friends. Trichinella is a parasite that used to be more important in the U.S. than it is now. It's still around, but not really one that's such a huge issue because not as many people or not make a living, but subsist on eating wild game, things like any sort of like rodent, squirrels, any sort of wild pigs. It can contain the trichinella parasite, and if a human consumes it, of course, if the meat is uncooked or undercooked, it's kind of our theme with all these parasites, then they could pick up a condition called trichinosis, which very frequently is fatal if you are infested with it. Now, that one, like I said, is not such a huge issue anymore in the U.S., but your grandparents or great-grandparents probably would have been more attuned to knowing about that one than most of us are now. Pinworms are one that is sort of interesting in that this one actually is of all the ones we're going to talk about, this is the most common one in the U.S. Now, those two numbers, 30% and 16%, are statistics for the U.S. 30% of kids, 16% of adults will experience pinworm at some point during their lives. Now, this parasite is not one that's fatal or lethal or anything like that. It's kind of gross, it's kind of icky, but it's not one that's a huge concern as far as killing you. The thing about pinworm that's kind of interesting is how it actually goes about laying its eggs. So the pinworms inhabit the lower reaches of the large intestine, and when the female pinworms are gravid or ready to lay eggs, what they're going to do is to migrate even further down the large intestine to the point where they actually exit the body, and that's where they're going to lay their eggs. All right, so once they lay their eggs, they attach those eggs to the skin in the perianal region using an adhesive substance, which is very irritating and causes a lot of itchiness in that region. So the thing that's kind of interesting about this is that they only do this at night. They are able to figure out when their human host is asleep. They're able to do this little migration where they then lay their eggs, attach them to the skin, and when that human host scratches the irritation or the itch, that is actually what distributes the eggs. And so the eggs at that point are then in the pajamas and the bedding and all those kinds of things. And once one person in a household has pinworm, it's fairly common for everybody in the house to pick up pinworm because the eggs are very, very resilient and resistant to chemicals and to going through the laundry and that sort of thing. So it's not at all uncommon for these things to spread throughout a family. Now, again, they're not really going to cause any great harm, but it is kind of disgusting if you think about it. Hookworms are one of the parasites I think that has one of the more fascinating life cycles. This one, again, back up until probably the maybe 1960s or 1970s in most of the U.S., was an issue. Not so much anymore. It was much more of an issue down south, actually, but it could be found in the northern states as well. Is one that if like a grown-up ever told you that you shouldn't walk around barefoot outside because you were going to get worms, this is what they were talking about. And this actually, there is some truth to that, although it's not really an issue anymore. If you walk around outside now, unless you happen to be walking in a place where there's a lot of human sewage, you're not going to get hookworm. And even then, you're probably not going to get hookworm because it's been more or less eradicated from this country. The way this works with hookworm is that its final destination where it wants to go is to the small intestine, where it can then essentially latch on, cut a hole, and then feed on the blood that's released. They're not very efficient feeders, so once they do that, that's actually going to cause a lot of excess bleeding, and actually can cause anemia, especially in younger people who have smaller bodies and just generally less blood. It can actually cause a fairly substantial amount of blood loss, up to about 150 milliliters per day per worm, which is not inconsequential. Where that becomes problematic, like I said, is in younger folks who are growing and need that blood to carry oxygen and nutrients to fuel that growth. In extreme cases, it can actually cause severe and irreversible damage to those people, even not only physically but mentally when it comes to development as well. because of this prolonged anemia that occurs. Now, the way the life cycle works, it's I think kind of interesting, is that the hookworm larval stage does burrow in through the soles of the feet, specifically between the toes where the skin's a bit softer, and it makes its way into the circulatory system. Now, once the hookworm is in the circulatory system, it's going to move through the body until it reaches the lungs, where it then comes up through the respiratory system, up the lungs, up the trachea to the back of the throat, where somebody who has hookworm in their system is going to feel a tickle, and that will then cause them to cough. When they cough, they then swallow the blood and swallow the hookworm, where it then makes its way to the stomach and eventually the small intestine. So that's how it gets to where it wants to go, is this through the skin, through the circulatory system, through the respiratory system, and eventually through the digestive system, where it can then feed on blood and also produce more eggs. So fairly long journey to get to where they need to go, but they're very effective at doing this. And like I said, this one does cause a bit of damage, especially in younger individuals. Ascaris lumbricoides is another one that we don't see in this country because, again, human waste is required for people to pick this up. But it's about 1 in 6 people in the sort of global population that has Ascaris lumbricoides. This one can also cause severe damage. It can cause death. They're rather large. They can produce about 30 million eggs during their lifetime. At their peak, they can do about 250,000 eggs per day, and they can live up to a year. So these guys are, 30 centimeters is pretty decent. That's about a foot long for a female, which is the larger of the two sexes. They are sexually dimorphic. So pretty good body size. And you can imagine if you had a few dozen of these in your large intestine or small intestine, it could cause a blockage, which can then again be can be fatal if a blockage actually causes a rupture to occur. So that one actually is fairly severe as well. Wisharia bancroftii is a cause of elephantiasis. This one, I'm going to wait to describe it until we actually get to a couple of pictures, but this one also is one that's very, very debilitating for people who have picked up that particular parasite. So now it's picture time. And so this first picture is of Diphtheria immitis. It is vectored or carried by a mosquito in their saliva. So if a mosquito bites a dog that has heartworm in its system, it will pick up some of the larval stage hookworm, or heartworm, sorry, not hookworm, but heartworms. The heartworms will be carried to a new patient. When that new patient is bitten, the heartworms will be infesting its body as well, and eventually the heartworms make their way to the heart, to the point where they actually feed on that cardiac tissue and can cause. This is actually a really severe infestation up here. This is more typical of what you might find, but the damage that's done to the heart's irreversible, and even treating it to get it removed from the system is very, very hard for the dog as well. So it's definitely one that's much better to prevent than try to fix after the fact. So the old saying about what an ounce of prevention is worth a pound of cure is very much applicable here as well. This is trichinosis, trichinella parasite, which normally goes between pigs and rodents. They sort of like pass it back and forth between each other. But if a human consumes either of these two without cooking the meat thoroughly enough, they can pick it up also. Now, for trichinella, humans are actually a dead-end host. They actually can't do very well. They don't do very well on a human host. So for them to get into humans is not really something they're looking for either, but it can and does occur from time to time that it gets into a human. It actually can be fatal as well. The Enterobius pinworm parasite. This is the one that moves from the intestine to the perianal region every night to lay eggs. Very, very tiny. Really about the worst harm this can do is disrupt the quality of sleep, which is not inconsequential, but not necessarily fatal either. That's a fairly common one in this country, like we talked about before. This is a scanning electron micrograph of the head of a hookworm, and this is what that looks like from the side. So we've got the hookworm feeding on the intestinal wall, feeding on the blood. These are big enough you can actually see them with the naked eye. This is actually from a colonoscopy where there was hookworm present, so you can actually see them there as well. And like I said before, through the feet, circulatory system, respiratory system, digestive system, and eventually to feed like they are in that picture there. This is Ascaris lumbricoides. So one of the things you get a sense for with a slide of one of these organisms is how much of their body is devoted to reproduction. So obviously you've got the pseudocele, you've got the intestine, you've got some muscle, but basically everything else inside the body of this female is either uterus or ovary. And so we're talking millions and millions and millions of eggs for these animals, which they need to produce those to be able to have any chance of success at all, creating next generation. But when you've got a parasite load like this in the intestine, very easy to cause a blockage, and from there, death is not too far off, most likely. These are sexually dimorphic. In this picture over here, the one on the left is female. She's going to be bigger. Fairly common, actually, in nature to see species that lay eggs, especially lots of eggs. The female is generally the larger of the two sexes because you need to have a bigger body to hold more eggs. Picture on the right, or the individual on the right, is a male. He's got that little hook on his tail, which he uses to hold on to the female while they mate. And of course, his body's going to be a little bit smaller because sperm cells don't take up that much space. Now, this next slide does have a graphic picture on it. So I always like to warn people here, if you are at all squeamish, if you don't want to see this, it would be a good time to look away. And I'll let you know when it's passed, and then you can look back at the slides if you don't want to see it. So the reason why I'm showing this next picture is not to try to gross anybody out, although that does typically do that as well, but to show you that these parasites, one question I'm typically asked in class is, okay, what happens if you have these parasites? Like, how do you get rid of them? And so there are drugs you can take that make the parasites either die or try to make their way out of the body on their own. And when they do that, they're going to try to do that through the closest possible exit. All right, so I'm going to go ahead and change the slide now. We'll get a sense for that. Then I'll change slides again and let you know, so nobody's grossed out that doesn't want to be. All right, so the parasites are leaving the body throughout wherever they can. All right, so now we're back to a point where things are not gross anymore. And this life cycle is actually kind of similar to hookworms, not too far off from a hookworm life cycle, but without human waste in the environment, really no risk of Ascaris lumbricoides infestation at all. So not really one that we have to worry about too much in the US. This parasite, actually, I didn't have a picture of this one before. This is a roundworm parasite that inhabits the eye. It's one that it's called Loa loa, I believe. It's a tropical parasite, which is, again, carried by mosquitoes. And the parasite actually feeds on blood within the eye. So it's kind of difficult to remove. You see it up here in this picture, sort of being teased out of the eye, not really scraping the eye or anything like that, but just trying to remove the parasite from the eye here, and then eventually kind of success over on this picture. But not pleasant at all. Elephantiasis is another interesting one, which, to understand what it does and how it does it, I've got to talk a little bit about the lymphatic system. So the lymphatic system is sort of like a cousin to the circulatory system, and what it does is that it helps to return fluid lost from circulation back into the bloodstream. So later on, when we talk about circulatory system, one of the things that we're going to see is that high pressure blood, when it enters into a capillary, tends to lose a fair amount of fluid. Some of that fluid goes out of the capillaries and goes into the surrounding tissues. It's the job of the lymphatic system to capture all that lost fluid and move it back into the circulatory system. Now, this parasite, this is Wuchereria bancrofti. This parasite, again, is carried by mosquitoes, different species of mosquitoes for all these parasites, but the parasite gets into the lymphatic system and it tends to set up shop in the lymphatic vessels or the lymph nodes where it causes a blockage. Now, this individual here has a blocked lymphatic system in their leg. Typically, the worst of this occurs below the waist. So you see massive fluid collection and edema, swelling below the waist in the legs, especially very severe case down here, obviously. This is all fluid inside of here. And so without getting the parasite out of there, that edema, that swelling doesn't go away, and it's extremely debilitating, although apparently not so debilitating that you have to stop smoking. Anyway, you got to get rid of the parasite, you got to drain the fluid, and then eventually, probably with some reconstructive surgery, if possible, you could get back to normal. Now, again, this occurs in parts of the world where medical care isn't the most available necessarily, so if somebody has an infestation like this, it might be fairly difficult for them to return back to normal. So it's definitely one that can be very debilitating. Very hard to walk around with that kind of swelling going on. Our other group of pseudocoelomates that we're going to cover is the rotifers. And we're not going to spend nearly as much time on them, but rotifers are very, very, very tiny, strictly freshwater organisms that are not only pseudocoelomates, they're bilaterally symmetrical, they're unsegmented, they're very small, they're microscopic, but they still have a fair amount of complexity, right? So they have organs, they have little organ systems, and despite being very, very small, are actually fairly complex. Now, up here on the top of this organism around the mouth, there is a structure which is unique to the rotifers called a corona. So corona means crown. In this case, the crown is made up of cilia. And these cilia are what the rotifers use to sweep food into their mouths and feed, essentially. They use that to capture food. The food then goes into the GI tract, and that's actually how they make a living when it comes to eating. But it's unique to this group. There's only about 1,800 described species. Like I said, very, very small, fairly complex. And one of the things about rotifers that we find a lot with these kinds of organisms that live in these kinds of habitats, freshwater places that dry up frequently, little ponds, even puddles in some cases. The rotifers are there for a while, but as soon as that water starts to dry up, they have to find a way to make it through the period of time when the water is gone. And so they can actually go into a resting stage, like an extreme hibernation stage, where they become completely metabolically inactive for really long periods of time, maybe even years in some cases or longer, until the water returns, at which point they reanimate and they go about, their business. Tardigrades do this as well. Water bears, if you know of those, are kind of the same way. Their habitats are very temporary. They tend to dry up, so they're going to be really helped out by the fact that they can go into this period of dormancy and remain inert for long periods of time. The Acanthocephala, we'll talk about those for a second, just because this is another really good example of convergent evolution. I'm not going to go into the details so much, but we'll talk about them a little bit. These are another parasite of vertebrates. Fishes are the most heavily parasitized, followed by birds, reptiles, amphibians, and then mammals. So fortunately for humans, we don't really have, or mammals in general, we don't really have too many acanthocephalan parasites, but in the fish world, that's a much different story. Now, what I'm going to do is describe a little bit about the biology of an acanthocephalan, and I want you to see if you if you can figure out who this is familiar to, or who it's similar to. Right? So the anterior end is covered in hooks. They are typically not going to have a digestive system. Their proboscis, which is kind of like their snout, sort of, is going to be arranged with hooks and suckers and things that are unique or diagnostic to species. They actually identify these based on their frontmost segment, if you will. They are dioecious, which is a little bit different than the other group that I'm thinking of, but they are sexually dimorphic. So in this group, they're not hermaphroditic. They're either male or female. They're not both. But again, they don't have a GI tract. And so this is another really good example of convergent evolution between the acanthocephalans and the Circomeromorpha, or the tapeworms. Now, again, we're in completely different phyla here. They're not within the same group. They're very different groups, but they have come up with a very similar approach to their lifestyle because they do the same kind of thing that tapeworms do. And so they've evolved a similar set of traits. No GI tract, no eye spots, a set of hooks to hang onto the inside of their host. Very similar to those organisms in some cases as well. Most of these also have an arthropod intermediate host, so either a crustacean or an insect of some sort. That's how they're going to find their way into their primary or definitive host, is by going through an arthropod secondary host. The only species of acanthocephalan that's thought to even possibly infest humans is one called Maniliformis maniliformis. This one typically goes between rats and cockroaches, but if a human were to be exposed in just the right way to a large amount of debris from one of those two species, could possibly pick up the parasite. But it's almost more like we talked about with the Trichinella parasite, where it doesn't normally get into humans and only sometimes does, that it becomes a problem. Most of the time, this parasite has no interest in getting into humans, and even if it did get into a human, probably is going to die as the end result. So that's kind of a similar situation there. Just a couple of pictures here. We see that proboscis with the hooks on it. Same thing here. This is a cutaway view of the intestinal wall, I believe, of a duck. And all of these little dangly things here are acanthocephalan parasites that are holding on, and they'd be feeding on the nutrients that the duck has consumed. Now, if you imagine that kind of folded back into a hollow cylinder like an intestine normally is, this duck's intestine was completely blocked by parasites, and it probably was having a fairly difficult time making a living with that kind of a blockage to its intestine. So not at all trivial for that particular host. So with that, we're going to wrap up this chapter. It's been a long one, but our next chapter is going to be even longer, probably twice as long actually, because we have to go through crustaceans, and we have to go through mollusks, and we have to go through insects, and there's all kinds of things, annelids and also echinoderms. So we're going to wrap up this chapter now, and we'll get started with our next chapter here in just a second.